serve as your pre-recorded video for our last topic in general chemistry, which is the bond polarity and electronegativity. So this would be the last coverage for our midterm examination. So before we will go to the topic, let's know first the learning objectives, or what are our goals to be exact in this lesson. We will identify the factors that contribute to a chemical bond's polarity, explain electronegativity, and also lastly, predict bond types to its electronegativity differences. Okay, let's proceed. So these are the topics or the key points that we will be learning in this lesson. So the unequal sharing of electrons within a band leads to the formation of electric dipole, or a separation of positive and negative electric charges. We will be knowing that after this lesson. To determine the electron sharing between two atoms, a table of electronegativities can determine which atom will attract more electron density. And lastly, bonds can fall between one of two extremes, from completely non-polar to completely polar. So within the lesson, we will be knowing this three key points, or these important key points in our topic. So we will be knowing this along my discussion. Okay, let's proceed. Bond polarity. So let's proceed on defining what is bond polarity. So bond polarity, it is the separation of electric charges along a band leading to a molecular or molecule or its chemical groups having an electric dipole or dipole moment. To explain it, when we say bond polarity, it is the separation of among the charges of the elements. So what are those charges? We have positive and negative charges. That's why it's called dipole or dipole moment, or electric dipole or dipole moment, because in this time, in bond polarity, you will be separating the positive or the charges of each element. So what are those charges? We have positive charge and negative charge. Okay, continue. So an electric dipole moment is a measure of the separation of positive and negative electrical charges within a system. That is a measure of a system overall polarity. As I've said, that when we say electric dipole moment, or this dipole moment, it is about the separation of the two charges. So electric dipole moment happen in the band polarity. So in that time, the element itself will separate the both charges, which is positive and negative. And the SI unit for electric dipole moment is called coulomb meter. So always remember that one, that the SI unit for electric dipole moment is the coulomb meter. So let's proceed to another slide. So this pictures or illustration shows the formation of electric dipole moment. As you can see, we can see the two charges here that being combined from the positive itself to the negative. So that is what happened to the electric dipole moment, or if the element is in the band polarity, the electric dipole moment happen, which is we will be separating, or the charges of the element itself will be separating. So what are those charges? Positive and negative. Okay, next, let's go now to the polarity of the band arises from the relative electronegativities of the elements. Okay? So in a covalent bond, electrons are shared in a bonding orbital between the two nuclei. So we already discussed the different types of chemical bonding, and one of the bond type of chemical bonding is covalent bond. When we say covalent bond, it is the electrons is being shared. So there is no such thing as acceptors, but always sharing. Share lang si covalent bond. So if it is a homonuclear bond between atoms, when we say homonuclear bond kasi, it is between the same element like hydrogen, nitrogen, oxygen, and chlorine. So the bonding electrons are shared equally, and the charges distribution around the bond is symmetric. So when we say So literally, the definition or the meaning of this statement is that kapag magkapareho ang isang element, kapag magkapareho or if it is the same, it is called homonuclear. Okay, homonuclear. So since it is the same, meaning to say they shared equally charges. And when they shared equally charges, it is called asymmetric. Again, homonuclear is meaning or literally the definition for homonuclear is when the elements is with the same elements. Okay. If there is the same elements, it is homonuclear bond. And if it is the same elements, meaning to say it shared electrons equally. And in that process, it is called symmetric one. Okay? When we say symmetric, the electrons can be shared equally. Okay? So that's it. That is a homonuclear bond and the term called symmetric. So let's move. So this is actually now the what is the explanation in the last slide. So the orbitals of two atoms of similar electron negativity come together to form a symmetric nonpolar covalent bond. Meaning to say, yun nga sinasabi ko, when we say homonuclear bond, homonuclear bond, meaning to say the element is having the same electronegativity. Magkapareho sila, and if in that case they shared equal electrons. Opo, kasi since magkapareho sila, meaning to say they can share equally what they call this electrons. And if they can share equally electrons, that is called as symmetric nonpolar covalent bond. Okay? Please remember that. Let's proceed. Over orbitals. So in contrast with that, kapag hindi naman magkapareho yung electronegativity ng element mo, meaning to say, it is not symmetric. So, it is called as asymmetric polar covalent bond. Kasi bakit? Bakit hindi magkapareha ang electronegativity mo? Kasi hindi magkapareha ang element. So, when the element is not the same, it is called as, to the other slide, we have heteronuclear bond. But if the element is the same, it is called homonuclear bond. Okay? So this illustration represent the dissimilar electronegativity, meaning to say the two atoms or the two elements has dissimilar electronegativity. And when we say dissimilar electronegativity, meaning to say the electrons cannot be shared equally. So if it is cannot be shared equally, it is called as asymmetric polar covalent bond. Okay? Let's move forward now. Ito na nga yung sinasabi ko in my discussion in the previous slide. If it is a heteronuclear bond, like for example hydrogen and chlorine or hydrogen and carbon, the electrons may or may not be shared equally. Okay. Meaning to say, the hydrogen is not the same element to the chlorine, right? The hydrogen is not the same element to the carbon. So it is called as heteronuclear bond. But if we compare it to homo, okay, homo said the same element, like for example, that's why I put subunits to, meaning to say hydrogen, hydrogen, nitrogen, nitrogen, oxygen, oxygen, and chlorine, chlorine. Meaning to say they are the same element and they can share equally the electrons. So that is the comparison or that is the differences between homonuclear bond and heteronuclear bond. Okay, let's go now to this slide. So, yun na nga sinasabi, kapag hindi magkapareho yung elements, meaning to say, the electrons may or may not be shared equally. May possible pa pala siyang ma-share and may possibility din na hindi siya ma-share because the element itself is not the same. So, the summarization for the both heteronuclear bond and homonuclear bond, equally shared electrons result in a nonpolar bond, while unequally shared electrons result in a polar bond, where one atom feels a partially positive charge and the other atom feels a partially negative charge. So always remember that if it is equally shared electrons, meaning to say that is called as a nonpolar bond. To be specific, it is symmetric nonpolar bond kapag bumibigay ng equal na share ng electrons. But if it is non-equal shared electrons, or kapag bumibigay ng hindi magkaparehang electrons, it is called as polar bond, or to be specific, it is called asymmetric polar bond. Okay? That explains the statement here in this slide. Okay, next. So, this is the representation of nonpolar, or the differences between polar and nonpolar. Okay, the term polar and nonpolar usually refer to the covalent bond. Why? Because covalent bond is all about sharing of electrons. So, meaning to say there are two types of the term covalent bond, which are polar and nonpolar bond. Okay, let's proceed. A completely nonpolar bond occurs when the electron negativity values are identical and therefore have a difference of 0. So a completely polar bond or ionic bond occurs when the difference between electronegativity values is large enough that one atom actually takes an electron from the other. Yes, kasi yun na nga sinasabi ko, when we say nonpolar, it occurs when it is the same element, and then the electrons of it will be equally be shared. While in the polar bond, it is actually correct with the statement, because again, polar bond, it is not the same element, and of course in the sharing of electrons, it cannot be may be shared electron equally, or may not. Meaning to say, there are possibilities that it can be shared equally, but there is also possibilities that it cannot be shared equally. Okay? So let's proceed. So in summary, nonpolar covalent bond has symmetric bonding, orbital electron density function with an equal sharing of the bonding electron, while polar covalent bond has an asymmetric bonding, orbital electron density with non-equal sharing of the bonding electrons. Yun na nga yung sinasabi ko kanina, that when we say non-polar covalent bond, it is from the symmetric bonding. Kasi bakit? It has the same element and the same equally shared of electrons. Why polar covalent bond? Asymmetric. Why? Because it is not the same with regards to the element, and of course, with the sharing of the electrons, it cannot be shared equally. Okay? Let's proceed. Any questions, clarifications about nonpolar and polar? So if you have question, you can give your clarification in our GC, or you can PM me. So now let's proceed to another topic, which is electronegativity. Okay? Electrons are not always shared equally between two bonding atoms. One atom might exert more of force on the electron cloud than the other. This pole is called electronegativity, meaning to say there are elements that has a power to attract electrons. Like for example, I will be giving you an example of what element that can be attract mostly. So let's proceed. There are key terms, or another important thing that we will be going to know in electronegativity. Electronegativity is an atom tendency to attract electron to itself in a chemical bond. Yun na nga. Like I've said, there are elements that has a power to attract the other elements. The most electronegativity element is called fluorine, and the least electronegative or most electropositive element is francium. Again, among the element in the periodic table, the most electronegativity element is fluorine. Meaning to say, fluorine can attract the other element because fluorine has the ability of having the most electronegative element, while the least electronegativity or most electropositive element in the periodic table is called francium. So meaning to say, francium is the least one. Hindi siya makaka-attract with the other element because it is least electronegativity, or that francium produces least electronegativity. Okay? The greater the difference between atom electronegativity values, the more polar and the chemical bond formed between them. So we will be discussing that furthermore in this next slide. So let's go now on the definition of electronegativity. As I've said, electronegativity is a measure of the tendency of an atom to attract a bonding pair of electrons. So meaning to say, if the unequal sharing of the electrons with the bond leads to the formation of an or please be reminded that if it has an unequal sharing of electrons within a bond leads to the formation of an electric dipole or the separation of the positive and negative electric charge. Yun ang sinasabi ko na electronegativity is focusing on the attraction or on the equal sharing of electrons, while if there is happen that it has unequal sharing, it leads to another process which called yung kaninang discussion natin, electric dipole, or electric dipole is called as the separation of positive and negative electric charge. Let's move forward. So this is actually the representation of electron negativity from low to medium and high. Okay. So you can also you can also see this in the periodic table, in your periodic table. Merong electronegativity dyan, makikita sa pinaka lower part, di ba? We have in a certain symbol, in the periodic table, symbol. Then after the symbol, we have the very first number. We have the upper one in the box sa periodic table. We have atomic number, then hydrogen. Then we have atomic weight, oxidation state, melting point, boiling point, density, and the last one is electronegativity. So you can check the electronegativity here or in the periodic table kasi it is the same. Okay? So let's move now. So atoms with high electronegativity values such as fluorine, yun na, this is the explanation between the range of electronegativity from low, medium to high. So again, high electronegativity values such as fluorine, oxygen, and nitrogen exert a greater pull on electrons than do atoms with lower electronegativity values. In a bond, this can lead to an equal sharing of electrons between atoms, as electrons will be drawn closer to the atom with higher electronegativity. Yun na nga, sinasabi ko in my explanation that if the element has a most or high electronegativity, meaning to say they can attract the other elements. So what are those elements that has a high electronegativity? We have fluorine, oxygen, and nitrogen. So meaning to say this element can attract the different element of the periodic table. Okay, let's proceed. So by this mean, you can eventually explain what is electronegativity. Like say this, in this man, is your electronegativity high because you're attracting me? So it's like a pickup line. So by this definition, or by this meme, you can eventually explain or know what is electronegativity. So the same with the other meme, oxygen is highly electronegativity. So as you can see, the big circle there is the oxygen, and the smaller one is the element that is least in terms of electronegativity. Nakikita mo, lahat ng element na yun pumupunta kay oxygen because oxygen can attract other element because oxygen is highly electronegativity. Okay? Yan. So let's proceed. So yun na nga, high electronegativity, we have fluorine 4.0 and also oxygen, which is 3.44 or 3.5 to be exact. Okay? So if two bonded atoms have the same electronegativity values as each other, they share electrons equally in a covalent bond. Usually, the electrons in a chemical bond are more attracted to one atom. The more electronegative one than the other, this result in a polar covalent bond. Okay? This is pertaining on the bonding types of bonds. So meaning to say, if the two bonded atoms have the same electronegativity, it is in the covalent bond. And if that will happen, the electrons in the chemical bond are more attracted to one atom, meaning to say, than the other one, meaning to say it will result with the type of covalent bond, which is polar covalent bond. Okay? So here, if the electronegativity values are very different, the electrons aren't shared at all. One atom essentially takes the bond electrons from the other atom, forming an ionic bond. So, inuulit ko, sorry, that if the electronegativity values are very different, the electrons aren't shared at all. So meaning covalent bond is not present in that. Kasi covalent bond is about sharing of electrons. If the one atom essentially takes the bond electrons from the other atom, forming, it is now resulting from another type of bond, which is called as ionic bond. So always remember that one. Okay? Let's proceed. So now let's go to the predicting bond types from the electronegativity itself. Okay, so let's just move. This is actually a representation. Let's just move with the exact explanation of it. Like for example here. So these are the electronegativity differences and bond types. So, differences in electronegativities of combining atoms and type of bonds. So, if the electronegativity of a certain element is from 0 to 0.5, the type of bond of it is nonpolar covalent. If the electronegativities of combining atom is from 0.6 to 2.0, it is a type of bond which is called as polar covalent. If it is higher than 2.0, meaning to say it is ionic bond. So let's proceed now on the calculation part. So it is very easy. Why? Because you will just subtract the electronegativity of each element in a compound. So predicting the bond type using electronegativity difference is shown below. Example number 1. What if your compound is sodium chloride or sodium chloride? So meaning to say you have two elements. We have sodium and chlorine. Okay, you will just get the what? You will just get the electronegativity of each element. So chlorine is 3.0. You can get it in the periodic table or in the table kanina na pinakita ko. Then subtract it to the electronegativity of sodium. So what is the result? It is 2.0 valence electron. EV stands for valence electron. So meaning to say the compound sodium chloride is ionic bond. Why? Because let's look with this illustration. Higher than 2.0 is ionic bond. Higher than 2.0, it is 2.1. So meaning to say sodium chloride is ionic bond. So let's go now to H2O or water. So there are two elements. We have hydrogen and oxygen. Again, you will be looking for the electronegativity. So for the hydrogen, we have 2.1 valence electron or electronegativity, and 3.5 electronegativity. So you have to subtract it. So it is 1.4 valence electron. So meaning to say if it's 1.4, it is polar covalent bond. Let's move yon polar covalent from 0.6 to 2.0. Next would be Next, we have nitrogen oxide. So there are two elements, nitrogen and oxygen. So nitrogen, we have for the electronegativity, we have 3.0, and oxygen we have 3.5. Okay. So again, you have to subtract the both of them. You have 3.0 minus 3.5, so it is equal to 0.5 valence electron. So meaning to say it is non-polar covalent bond. Why? Non-polar is from 0 to 0.5. So that is very easy, right? So you have to just subtract their electronegativity from the compound itself, from the two elements that being bonded. Okay? So, check your understanding. Identify the bond types for the following. We have KO, potassium oxide. We have also MgO, magnesium oxide, and we also have CO2 or carbon dioxide. We also have BaCl, or let's say, or barium chloride, and we also have ZuSu or zinc sulfur. Okay, so sige, let's try your understanding. So I solve for number 1. So try to solve for number 2, 3, 4, 5, and please picture your answer and send it to me. Send it to GC na lang so that compile yung answers nyo. And that's it. That is the end of the band polarity lesson. So that this is the end of the coverage for your midterm. Please view and watch the video because this is your last discussion. Thank you very much and have a safe day.